Nickel-cadmium. Nickel-cadmium batteries were one of the earliest rechargeable battery types used in mobile devices, especially in the early days of portable electronics. They store energy through a chemical reaction between nickel oxide hydroxide and cadmium, which made them reliable and capable of delivering consistent power output. One of their main strengths was durability, as they could handle a large number of charge and discharge cycles without failing quickly. However, they became known for the memory effect, where the battery would remember a smaller capacity if it was repeatedly recharged before being fully discharged. Over time, this reduced the usable battery life in everyday situations. Another major issue was the use of cadmium, a toxic heavy metal that posed environmental and disposal challenges. Because of these limitations, nickel-cadmium batteries gradually disappeared from mobile phones. Nickel metal hydride. Nickel metal hydride batteries were introduced as a more advanced and environmentally friendly replacement for nickel cadmium. Instead of using cadmium, they rely on a hydrogen-absorbing alloy, which significantly reduced toxicity and made disposal less harmful. They offered a higher energy density, meaning they could store more power in the same physical size, which directly improved battery life in mobile devices. The memory effect was still present, but much less noticeable, making them easier to use without strict charging habits. These batteries became common in feature phones and other portable electronics during the late 1990s and early 2000s. However, they had their own drawbacks, such as a relatively high self-discharge rate, meaning they would lose charge even when not being used. As mobile phones started to demand thinner designs and longer-lasting power, nickel metal hydride batteries began to fall behind more efficient technologies. Lithium-ion. Lithium-ion batteries represent a major turning point in mobile battery technology and are still the most widely used type in modern smartphones. They work by moving lithium ions between a positive and negative electrode, allowing energy to be stored and released efficiently. One of their biggest advantages is high energy density, which means they can store a large amount of power while remaining lightweight and compact. This made it possible for smartphones to become slimmer while still lasting longer on a single charge. Unlike older batteries, lithium-ion does not suffer from a significant memory effect, so users can charge their devices at any time without damaging long-term capacity. They also support fast charging and are better suited for handling the power demands of modern processors, displays, and connectivity features. Despite their advantages, they require careful management systems to prevent overheating and ensure safety. Lithium-polymer. Lithium-polymer batteries are an evolution of lithium-ion technology designed to offer more flexibility in both form and function. Instead of using a liquid electrolyte, they use a gel-like or solid polymer electrolyte, which allows the battery to be shaped into thin and custom designs. This is especially important for modern smartphones, where internal space is limited and design plays a crucial role. Lithium polymer batteries are generally lighter and can be made safer in terms of leakage risk, as they are less likely to spill compared to liquid-based batteries. Their performance is very similar to lithium-ion, including high energy density and support for fast charging. But their real advantage lies in adaptability and design freedom. Because of this, they are widely used in today's slim and premium devices, where both efficiency and form factor are equally important.